All right, should we go ahead and start? Hi, everyone. Thank you for joining us today. This session is on the NASA data processing levels, the standard data processing levels that we have. And we don't have a real firm hypothesis that we're trying to prove here. We are really in an exploration mode. So we're trying to understand the processing levels, and there has been a movement to revamp them. And we're trying to figure out whether that's something we actually need to do or not. So it's a completely open, um, you know, horizon here. Okay, so we're going to start with a quick overview by Steve Olding of ESCO. So I don't know how to make the slides move forward.
Okay, you work on slides. So we are ESCO,
Oh, is it this one?
Standards Coordination Office.
Thanks.
So as the name suggests, we're interested in standards for NASA's Earth Science data products. We do several things. One is, we maintain a list of the approved standards for NASA Earth Science data systems. We also run the ESLIS standards process. That's the mechanism by which new standards become officially blessed as NASA Earth Science data system standards. So some of you will probably have heard from us and be invited to review. So our process really starts with the submission of what we call an RFC, or a request for a comment to ESCO. Which is really sort of requesting that a new standard or guideline be adopted by ESLIS. So we do our initial review of that, make sure it's sort of basically readable, reasonably coherent, and then we go out and look for community expertise for feedback on it. So it's a community-driven process. We look for people both within NASA, but also NASA data users in the Earth Science community. So the folks from ESLIS. We go through this review process. We get the comments. We may need to revise and go through a sort of second round review. So this is kind of like a sort of a peer review process, at the end of which we should come out with an adopted, endorsed standard that meets the need of the NASA Earth Science community. So that's really what we do. Data processing levels that came to us, we were kind of like aware that there were people juggling around and doing things a little different. So that's how it sort of come to ESCO to sort of take a look at. And I'm going to pass back to Beth to tell you what we found.
Great. Thanks, Steve. So just quickly, these are the processing levels that are currently the approved standard for ESTIS. There are 5 of them. Lots more are in use. I'm not going to read these to you. Just know that they're kind of go from raw data to model outputs, and then the stuff that's in between. And we're going to talk more about these later. We're going to have a discussion session at the end, so we have plenty of time to complain or praise or whatever. Oops. Uh-oh. How do I go backwards? Sorry, team.
You need to go back.
Yeah, I need to go back. Oh. There we go. Yeah. Okay, so as Steve mentioned, there's been a little bit of muttering about these processing levels and whether or not they're adequate. So one thing that has happened is, for starters, we've got the standard approved processing levels, and then we've got the ones that are actually in use. So these highlighted ones are not part of the approved standard, but they're actually being used in the CMR. Data sets are labeled, or data products are being labeled with these non-standard processing levels. As you can see, some of them don't even have definitions, so we don't know exactly why they're being used or why the approved ones weren't adequate. So we are, looking to get to the bottom of that. Some of the definitions may be unclear to people, right? It's not, the more we've looked at these, the more we've agreed that maybe at the very least we need to review the definitions and possibly clarify them a little bit. The definitions are old, guys. This is from a 1993 um, Earth Observing System Reference Handbook. These are exactly the same processing levels that we have today in the standard document. So it's possible that we're due for a review. And so, another reason that we are here. The ESCO team undertook a very informal survey of UWG members. We got a whopping 4 responses. So, so I don't want to say this is, a definitive or scientific survey, but we asked user working group members to tell us how they were using processing levels. And this is what we got back. They're, being used for data discovery, data visualization, data regridding. I can't say I know how they're using them in this capacity. I mean, I think we can guess how they're using them in discovery. The visualization, regridding, resampling, reformatting, interpretive data analysis, and data subsetting. People say they're using them in that for those tasks. I'm not exactly sure how. We asked them what tools and services they were using processing level information. So this was about processing level information, the metadata that specifies what the processing level is. And I can't even say that that was clear. I'm not sure. But these are the tools that they claim they're using this information with, right? So lots of tools: Earth Data Search, Google, Bing, Yahoo, ArcGIS, Panoply, HDFU, Harmony, Subsetter, Google Earth. So, I mean, if our 4 UWG members are representative of the world at large, then the processing levels are useful to people. And then we wanted to know how they're consuming the information and, whether it was just strictly a human reading the processing level or whether it was being used in some automated way. The responses suggest that they're being used in an automated way. One of the possible answers was without any human intervention, a software system, consumes the information and makes use of it. So there you have it. As I say, it was very informal and I don't know how to interpret these results at all. So I'm going to just put them out there for us to contemplate. Holy cow. Oh, it's like, God, why did I include this slide? Um, what is this? This is this is an entry in the Earth Data Forum where there is some talk about processing levels. So people are out there doing their own processing, right, and using tools to do that, and so that's another area where this might be relevant. I just wanted to throw that out there that, here's a discussion that came up on the forum. A person was trying to go from level 2 to level 3 using some kind of software or script that they wrote, and the response is, "Oh, that's hard. Um, I don't know if you want to do that." But so the bottom line is, we've got a lot of different processing levels out there, and then people even doing their own processing, and so a question is. Whether or not that is things are adequate as they are. We've got 3 guest speakers lined up today, and we're going to have them come and give you some more background on use cases. Valerie Dixon from ESDIS is going to talk a little bit about stats from the CMR on the use of processing levels in search.
All right. All right. I apologize, folks. I didn't get my slides in our approval process in time, so I have to share them on my screen instead of share them on the Google Doc. It's okay. I can hold it. That's fine. All right. So I'm going to skip through let's going over the reviewing of what processing levels is. So we just went over that. This is just going to be a brief metrics dive into how processing levels are being used in our Earth Data Search tool and in CMR. So in particular, our Earth Data Search, which was one of the tools that folks are using for search and discovery, we surface facets over on our left pane here. You can see it highlighted in red here. We got processing levels. You open it up, you see these various processing level options. You can select them, and it down filters the search results. You can see it went from, 10,000 results to 100, right? So this is a good, easy way that some of our users use our tool to find data by processing level. Now, Earth Data Search is really just the GUI front end to our CMR Search API. So when we were looking at metrics of how processing level is actually being used, we didn't look at Earth Data Search's metrics, we looked at CMR's metrics because we wanted to make sure we caught them all. So looking into those search metrics a little bit, initially, it looks like we use processing levels a lot. We get hundreds of thousands, in some cases, millions of queries by processing level. And you can see the breakdown here. This is just a snapshot day in the life of, weekly averages, monthly averages, and a yearly average of, broken down by processing level along the bottom there, which you can't see because this is blocking it. If I can hide that. So you can tell here that the higher the processing level is, the more frequently people seem to be searching for it. So, level 4 definitely being searched for more than level 1. And you think, wow, that's actually a lot more use than I thought, right? Until you put it in the... Yes, so processing level 4 was the most numerous one. Then this is by most to least numerous.
Okay.
Sorry. I flip-flopped on how to display that. Okay. So yeah, processing level 4 was the most used, followed by processing level 2 and other sub 2A, 2B iterations. I lumped those, and then 3, and then I left the ones broken out because they were different.
Oh, okay, and you've got weekly, monthly, and
yeah, weekly, monthly, and yearly.
got it. I was wondering what ours were.
Yes. So you can see that it accrues over time. The trends look good, and it looks like it's heavily used. Those numbers are big, and then you put it in context with all of our other CMR queries. And these little non-existent lumps off to the left here, those are the processing level queries for our weekly, total queries across CMR, our monthly total queries, our yearly total queries. Now, weekly, I think, was a little bit higher when we took these metrics because we were preparing for this presentation. Skewed the metrics just a little bit. So looking at like the monthly and the yearly averages for all of our CMR holdings, processing levels only really being used 2 to 6% of the time, which is, it's still a lot of users by number, not a whole lot of users or queries by percentage. And so some of the question is like, well, how used is this? Are we going to go by the bare numbers? Are we going to go by the, percentage of our total user base? Not quite entirely sure what conclusion to draw.
That's pretty much where we are too, Will.
I'm stacking all my questions. You want to do this at the end?
I think all the questions were going to be at the end.
We do have a big block of time at the end for discussion, and I think it might be better to hold it for then, just so we can make sure we get at all our speakers.
Where's the stop share?
I don't know where we are on time. I think we're fine. I don't think we have an overburdened agenda.
You needed your presentation. Are we continuing these slides?
Yeah, we're good on those. We're going to continue with my slides. Yeah. And yeah, I think we're actually.
I'd like to
Thank you,
introduce our next speaker, and this is Tom Myersberger. Tom is the Land Satellites Data System Product Manager at the USGS Aero Center, which operates the Landsat satellite program. Tom is also a former colleague at NASA's LPDAC, so he's very familiar with processing levels across the land remote sensing community. And he also has 30 years of experience as a technical and leadership roles. And today, Tom will be giving us an overview of Landsat Collection 2 data product processing levels.
Oh, sorry, I lied to you that morning. So sorry. We need Tom's slides right now.
That would be good. I mean, I'll do yours if you want to do mine.
Mine only saying we're gonna let all hear Tom. How would that helpful? Yeah, we're sorry.
So while we're getting queued up here, I will say currently Landsat program has we published collection 2 with all the different process levels, full reprocessing of the entire archive to the next major version that occurred in 2020. All of those data are publicly available in the cloud. I think most of you know this. One thing we're thinking about right now is collection 3. So we're going to embark on another full reprocessing campaign in the 28 timeframe. And now's the time when we're past formulation. We're really starting to get into design and specification for what will go into collection 3. And things like file naming conventions are one of the things we will look at, because collection 3 is really intended to be structured to have LNEX data fit into it when LNEX goes up in the 2030 timeframe. But this should be rather straightforward. In terms of collection levels, we have mission data, of course. Those are the raw data stream. Level 0 in our world comports very closely with the NASA definition of level 0. No big surprises there. At level 1, we do also align pretty well with the standard as is written, at least at the parent level. We do have variants, and these are sort of historical conventions that we've adopted really to indicate the kind of geometric quality that you might expect in any given scene product. So we have systematic, terrain, and precision. And I think when you guys see T, probably you've got like an Aster L1T, which sort of follows from this terrain precision correction idea. And so when you search or when you look at product file names, you'll actually see L1 and the variant in the file name. Otherwise, I mean, these are the calibrated radiances, digital numbers, really just sort of comports with what you think of as a level 1 product. Level 2 gets a little squirrelier. Level 2, we really mean land surface temperature and land surface reflectance. So these are atmospherically corrected. The way we package is a little bit different than some other providers. We don't have independent surface temperature and surface reflectance data sets. They're all together in one data set. There are cases where we cannot produce a surface temperature retrieval where we can produce surface reflectance. And so what that engenders here is these variants that we made these up, right? We made these up based on the context of what our processing does. So we have a level 2 science product. You'll see this in the file name, in the product indicators. L2SP, that will include both of those kind of parameter retrievals. Or in cases where we don't retrieve surface temperature, it's surface reflectance only, we'll have an L2SR. Okay, So just very context dependent variance based on our context. Now we also have this sort of tweener thing, which is level 2 analysis ready data. Whereas the scene-based level 1 and level 2 products are all in UTM unless they're in polar stereographic. Level 2 ARD is really more like a MODIS-like equal area, tiled sort of spatial presentation of the data. It's only for the continental US, Alaska, and Hawaii. And in this case, we kind of nominally call it level 2, but it actually includes level 1 data as well. It includes top of atmosphere data in scaled radiance, as well as the atmospherically corrected parameters and a whole bunch of other stuff too, including QA and lineage data and all this kind of stuff. When you go to look for ARD data sets, like in Earth Explorer or other places and in the file names, you will not actually see level 2 in the file name, but there is that notation in other places. So this ARD thing is kind of a little bit of a mashup, and certainly probably doesn't fit into a standard bucket as we know it. We've had people on our Landsat science team argue that ARD should be a level 3 product because we're actually joining scenes in some cases, depending on where the tiles lay. So you could argue that maybe that's a spatial aggregation. It's certainly not a temporal aggregation. There's no temporal compositing or anything happening at ARD. At level 3, we probably maybe even vary more from the NASA published standard. We consider the level 3 products sort of these more biophysical instead of geophysical data sets. So level 3 is produced from ARD. It's things like burned area, surface water extent, snow covered area, these things, which are a bit more biophysical, a bit more thematic. The end.
Great, thank you, Tom. So I think that was a brilliant way of making our point for us, Tom. Thank you so much. Okay. And then now we need the, Yep. Thank you.
So our next speaker is Jean Liu, and he's from Justice and George Mason University. And he's going to talk about how he uses NASA Global Satellite model data practices at Justice to illustrate NASA data processing levels for the tropical cyclone research and applications.
Thank you very much. Hi, everyone. My name is John Liu from NASA JASDISC. And also the title of today's talk, Bob just mentioned. Okay, so here is the outline of today's talk. Yeah, first a brief introduction followed by a description of data products at the JASDISC and their samples for tropical cyclone research. So it's a challenge to give a detailed description about the product in 10 minutes. So at the end, I will share my perspective on the data product processing levels. So tropical cyclones, as we know, form over tropical oceans where in situ observations are sparse and discontinuous. So data collected from satellites along with model reanalysis data plays an important role in providing observations, filling the data gaps, and enabling research on weather and climate research on different scales. So NASA JASDISC archive and distribute the satellite and the model data in several focus areas, including atmospheric composition, water and energy cycles, and climate variability. So data set from other NASA DACs are also important for tropical cyclone studies, but it is a challenge to discover and integrate this data set, yeah. So this table shows the past, current, and the future NASA satellite missions that are associated with their data product curated at the JASDISC. So in particular, the Tropical Rainfall Measuring Mission, or TRIM, the Global Precipitation Measurement GPM mission, the Modern Era Retrospective Analysis for Research and Applications, version 2, also known as MERA2, are frequently used for tropical cyclone research. So before giving details about the product, let's review the product processing level. So I'm not going to repeat this since this has been presented before earlier. So data product at the NASA JASDISC. So this table contains a list of a TRIM data set at the JASDISC, so based on the data processing levels. So this TRIM product have been a part of the GPM product family right now. So also the NOAA NCEP CPC 4-kilometer modular IR product covering 60 degree north and south can also be very useful for tropical cyclone research. This table lists the GPM data set at the JASDISC based on also based on the data processing levels. So in particular, NASA's integrated multi-satellite retrievals for GPM, also known as iMerge algorithm, combines information from the GPM satellite constellation to estimate precipitation over the majority of the Earth's surface. So iMerge has been a very popular GPM product suite. So it contains 3 data collections, early, late, and final, with different latencies for different applications. So the modern era retrospective analysis for research and application MERA2 products are also very popular for tropical cyclone research. So here are some examples of the products mentioned earlier. So on the left, you can see 2 tropical cyclones over the western Pacific Ocean. So in the middle, you can see the imagery from the GPM microwave images, also known as the GMI, cover over the Indian Ocean. On the right, it's the imagery from the GPM dual frequency precipitation radar, or DPR, showing the precipitation from a super typhoon near the Philippines. So you can explore level 3 data products with JASDISC Giovanni. Giovanni is a popular tool developed by JASDISC in the year of 2000. So and like a previous speaker mentioned, we also like Giovanni also generate a lot of analysis, and the people download the data for research or applications. So that can we classify as a level 3, analysis ready data? So that can be debated. Okay. So if you try to learn more about Giovanni, there's EOS magazine. We have a published paper there. Okay. So so with over 2,000 variables in Giovanni, finding a variable can be a challenge. There are several features such as keyword suggestions, facet, and sorting to facilitate variable search in Giovanni. So these are some examples from Giovanni. As you can see, it's very easy to generate visualizations from Giovanni. Oops. So now the perspective on data products and the services. First, let's take a look at the pros and the cons of using data processing levels. So Perot apparently, clear structure and standardization, and also flexibility for different user needs. For example, like a level 3, level 4, very easy to use with other software or applications tools. Improve data quality, reliability, such as quality control, enhance interoperability, like HDF5, NetCDF, counts complexity and the learning curves. A lot of people don't want to deal with, for example, HDF4. That's the main motivation to develop Giovanni. That's back to the year of 2000. Resources intensive, like processing, storage requirement, data loss at a higher level. And also dependence on processing algorithms. And also there are some other issues like naming conventions vary for different missions or projects. You can see the figure on the right. There are so many different guidelines. Also the data and the metadata standards, such as data structure, unit in variables, and also vocabularies. If you take a look at the GPM mission, they're so quite different, even from the TRIM mission. Also data quality, like uncertainties, and the user-friendly tools and the services to enable customized data subsetting, visualization, and analysis, like a world view. User probably don't care about the level, whether it's a level 2 or level 3 in world view, as long as they can see the image, So, and also data services such as collocation, coincident tools, and the services to connect data from different sources like satellite models, in situ observations for case study, such as tropical cyclones. So in conclusion, a collection of Earth's satellite and model data set is available for tropical cyclone studies, but the data gaps exist, especially in situ observations over oceans, for case study, algorithm development, and product validations. So different processing levels are designed to meet the needs of different users. And improvements, including naming conventions, data structures, documentations, and user-friendly tools and services to facilitate scientific research and application. I think that's all I have. Thank you very much.
Appreciate all of our speakers. Thanks. Now we're back to my slides.
Okay.
Okay, so the rest of this session we would like to have as discussion. We want to know, have we, do we have the right processing levels? I want to back up somehow or other. Just to look at, so I think one thing that our speakers demonstrated was that there's a real difference between the standards that we have, and hey, we're ESCO, so we're real sticklers for standards, y'all. We want you to use the approved standards, and that's clearly not adequate. We've seen two speakers who have demonstrated, I think, that the standards that we've got approved right now are not adequate. They're using they're having to designate different types of level 2 data, for example, using their own acronyms. And so one question that we want to try to start discussing here is, do we need to include all of these different kinds of considerations? Do we need more considerations in our processing levels? Do we need to add more of them? I had, for fun, was thinking that we could look at some, oh, why?
Should I go back? You want to go back?
Yeah,
Yeah, just do.
this one will
Yep.
do it? Okay, thank you so much. Oh my God. I just pulled some abstracts out of Earth Data Search for a few different data sets. And then I, put question marks in here for what the level they actually were proclaiming themselves to be. And I wanted us to start with just, kind of looking at these abstracts and saying, would you know what processing level to assign to this one? This is a Maya data product. It's a simulated product. They haven't launched yet, but they are going to have some data that is observational data, gap filled with model outputs. So I'm curious to know what processing level people in the room think that data product ought to have. Okay. Yeah. Okay. Right. It's got some model output. Yeah. Level 4. Tammy says level 4. Do people agree with that?
Should we show number of fingers?
Oh yeah. Hold up. Yes. If you think it's level 4, hold up 4 fingers. Okay. Deborah is saying 3. Right. I mean, I think that's a good point. Right. It's got observational data in it. It's also got model outputs. So yeah. Go ahead.
So I think I almost want to reject the question.
Okay, great.
Well, no, so I think we very much need to understand what is the user trying to get out of this. And as someone who's
Out of what? Sorry, out of this session or out of the processing levels?
processing levels
Okay.
in general.
Yeah.
And as someone who, I'm not a scientist, but I do use processing levels. And I think that might come up more often than we're seeing in metrics, partly because we stick the processing level in the product name. So even if you're not using the CMR filter, just looking at the product name, you're seeing L3, L2, those kinds of things that may or may not be meaningful. It would be hard to know. But the reason that I find this question maybe a little bit dubious is there's this other question of these are going to be necessarily very coarse-grained buckets.
Yes.
I mean, there's like, what, 5 to 6 of them. And there's this other question in my head of what should we do with something that doesn't cleanly fall in that bucket? Is it better to just leave the processing level off, maybe?
Yeah.
Than to possibly put a misleading processing level on something that then the user gets it and they're like, said level 4, but it's not even gridded. So what am I looking at here?
Yeah. Thank you. That's an interesting point.
All right, so yes, what is processing level exactly supposed to communicate and who is it really meant for, right? And 2, it's written from a satellite perspective. A lot of times the airborne and the field, we can't quite figure out where to place it. It's placing it at different levels because there's no description that connects airborne and field data cleanly to these levels in a way that everybody can interpret the same way. So we've got 8 counties of it.
So a number of the words that Patrick used are the words I'm going to use. What is processing level 4? I think it's a coarse measure of determining whether a data set is suitable for the consumer. And the more buckets we put in, the less easy, the more difficult it is for that user to figure out at a first approximation whether this is the data that this data is suitable for me. And there are a host of other metadata information that would allow them to refine that.
Excellent point. Yes, thank you.
One thing I would like to see in the metrics that we provided from CMR is the distribution of those non-standard data processing level attributions. Are they 1s and 2s? Are they 10s and 20s? Are they 100s? And finally, no disrespect to the people who presented, but they were all producers of data or stewards of data. And the question we're really asking ourselves is the consumers of data, I think.
Yes, thank you.
I think I have a radical suggestion. Leave the processing levels the way they are defined for the satellite products, and perhaps have a separate set of definitions for aircraft and field campaigns. That's one radical suggestion. And the other is when there is additional information associated with these products, such as greater characterization beyond level 2, for example, or level 3, attach suffixes or have a separate field that says, here's the additional thing that you need to do. Those are the kinds of things that Tom was talking about. So you don't really have to change the current set of levels for satellite products.
So if I can respond to that though, Rama, I do want to, let me back up here and just point out that what is going on is, whoops, this, right? The ones on the left are the standard approved processing levels. The ones on the right are the ones that are actually being affixed. And you're right, Doug, we should get some metrics, but we had, Tom talking here about why they don't find processing levels as they're defined to be adequate. So we ESCO are not taking a position. So we're not trying to say we should do this. I just am, playing devil's advocate here. We've got people, data providers who are saying, man, this doesn't really capture the nature of our data. And we will talk in a minute about users. So yeah, go ahead, Patrick.
Yeah, so I'm kind of trying to tee up Peter Strobel here. I don't know if he's online, but there's a contention there that really it's a coarse-grained, kind of to Doug's point, I wouldn't say it's how suitable it is to the consumer, but it's like how much work has already been done for me, and depending on who you are, less might be more. So, but it's trying to attach a number to a bunch of different, effectively, dimensions of things. And possibly what's more appropriate here is to have one field that's telling you, what can I expect in terms of geographic, geolocation information, and another completely different field that's telling you what can I expect in terms of science data values and how much those have been processed. Is this like some fused model output, or is this raw data to begin with? And maybe we should start separating things out. And I think we saw also in the USGS example that, I would contend that maybe some of the things that they're tacking on at the end are useful, like signifiers to a user, but maybe aren't processing level things, but processing level becomes a convenient place to put that sort of thing. So.
Yeah, good point, right? Is our processing levels the right place for this, or do we need to expand our metadata schemas?
So also in a field campaign, you will have different processing levels on the granules within that campaign. And so what do you do then? I can tell you what I usually suggest is that you go with the highest processing level, unless the bulk of the files are at a lower level, and it's a judgment call. So whatever we decide is standard, it's not a problem to adhere to that because we can make it a required field and not ingest it without people. But I think it's really important that we do come to some type of agreement here on what we can use to make sure that when the user needs to transform that data, they're transforming the data in a correct manner.
I think Tom and then Valerie next.
I mean, I will totally agree that the conventions that we use are very production centric. And, I've spent a lot of time interacting with end users, and typically end users don't really care that much about the peculiarities. They care more about what is the parameter what is its quality,
Mhm.
right? And so these, like Patrick said, that these are a little bit like stand-ins for what sort of parameter retrievals we have and sort of what is the quality. I actually think more clarity like in long names might help rather than suffering too much over the vagaries of processing levels. And I think the big buckets are probably sufficient, perhaps, as an indicator for how highly processed the data are, and allowing sort of context-dependent variance under that can be defined in particular specifications.
Okay, can you roll back that particular table that you showed me first? Yeah.
This one?
So the one that on the left-hand side was the one which the science teams came up during the early initial period of the bias. So the way it was done is level 0, the data directly from the instrument. Level 1A is the level 1A and level 1B is the calibrated reagents, the sensor, and level 2 is the same level as level 1, that is for data, but it is the science observation measured from the level 1. So level 1 and level 2.
Do you mean
are
science
direct
quality?
one-to-one
Science
observation.
quality, you mean?
Level 1 and level 2. Level 1 is the measurement as is from the instrument, and level 1A, 1B is the calibrated and reflected. It is top of atmosphere, right? So that's how it is. Level 1 is instrument data, level 1 is instrument data, level 1B is the calibrated top of atmosphere reflections and rays. Okay, that's how it is to be done. It's at the sensor measurement. And level 2 corresponds to level 1B, but it is the science parameters, reflectance, corrected reflectance, temperature, no, CRs. They are all geophysical parameters that is derived from level 1B, and they are still same instrument, track data. Level 3 is what is the map projection. These observations are projected into certain map projection, whatever you want. Sinusoidal, Lambert azimuth, what do you want? You just project it. It's still there. Now, at this point, there is a question. You lost now correspondent to that observation. So if you want to go back, then that has, because you are now resampling that data into the Earth projection map. So you have to be careful now, because you will see observations coming from different viewing directions. So if you want to preserve it, you can just do a resample and pick one, or you want to preserve all the level 2 observations. How do you want to do that? So the science team said, oh, now I have to do binning. Okay, so that is what is called level 2 grid. So you have a grid at 500 meters on the ground. There are so many observations, which are fractional observations by certain percentage which covers that grid. So you have to bin it up. If you want to track back into the observation, I have to bin up all those observations. And so, hey, at this 500 meters, you're going to see all of these observations, but at different percentage coming from different angles, right? So that is what is called level 2G. Level
Okay.
2 gridded. Level 2 is gridded.
We need you to write that definition and add it to the GCMD keywords.
Well, I think you need to have historical knowledge that has to be transferred for you to understand why that is like that. Okay, so that is level 2G.
Right.
Okay? It's going to be huge data when you get to level 2G because you really, subsample all of these observations and put it into a single grade. And so you're going to see 16, 17, 20, hundreds of observations at one point. You started with one observation, but now you have hundreds of observations. So that is level 2G. So you can distribute that. So they said, okay, I am going to composite that, and that is level 3. Now you are going to see one observation, a grid show, which is a composite of so many observations that comes into that. That is level 3. It is a composite of all these gridded binge observations.
Right. Okay. So
Now
your
we are
position
saying,
is that
that is level 4.
that the left-hand table isn't adequate. Is that a fair assessment of what your position is, that the left-hand table is inadequate? And we need things like level 2G, level 2P, level 3A,
Yeah, well, you can
1C.
You will see today a level 2 GA, right?
Okay.
That is because
Sorry, Valerie.
we want to minimize the certain number of observations to provide user with all the information about how you can test back to that level 2 for that particular observation. Okay? Because level 2, 3 is somehow aggregated, so there is no way you can trace back that observation information, right? So I can decide not to do that, but I will pick one of the best for that grid and put it there with all the information that is needed to trace back to level 2, which is called level 2 GA. So like that, people started creating all of these kind of derivatives of that. So, but fundamentally, that's what it is.
Okay, great. I think Valerie's been waiting to jump in here, and then Tom, and then Deborah.
Okay, thank you. So I think we're driving ourselves around the axle a little bit. I don't think that we need to have a level definition for every possible combination of what our data needs to be. And coming from an outside perspective, I'm not a consumer of processing levels, and I'm not a provider and producer of it either. But it seems to me that the old processing levels, as they were written in the 90s, were seen as a progression. The more processed you were, the higher your level was, and there was an assumption that the higher level you are, you also have all the attributes of those lower levels before you. And that's not true anymore, right? We've got model data that's not gridded. We've got, all of these other, sub-attributes and little subcategories, and maybe these levels as they were designed don't apply anymore. Maybe instead what we need to have is some way to, going back to some of the other comments, what is it that we're trying to achieve from this? We're trying to help people know what this data can be used for. Maybe we need to just have characteristics like it is gridded, it is time series, it is combined, it is, yada, 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 etc. And get those discrete qualities as opposed to trying to define all of these permutations as their own sub-level categories.
I'm a scientist from when this was developed. And yes, it is all, that you made my point, exactly. It is very focused on the satellite data processing, period. Right? And the thing is, we've got a much more complex world now with different kinds of data.
Actually,
So
it's
therefore,
not about
yeah.
data being processed. It's about also being how users should use it. Because
Yeah,
at the end of it, you don't know what it does.
Right.
You're going to misuse that data.
And it means only something, it only means something to the satellite data producers and those who try to use that satellite data that follows it, and it's built around that. It can't function for the rest of the kind of data we have. So we do need something else.
Qualities that we need to identify and just have those.
Yeah, you want to let Valerie say that? Okay.
Yeah, I mean, if you look at this as a classification problem, right? In your table, it's basically a classification, right? And so in any really good classification system, we want all the categories to be one comprehensive list. They're all mutually exclusive.
Mm-hmm.
Well, just doesn't function like that.
Right.
Right. So I think we all understand as you go up in processing. It's further processed. The lower things are inputs to the higher. So the directionality is fine. But I don't think you're going to have a classification system that covers every area.
Yeah, I want to tee up some questions for us too, some specific questions. These came from Peter Strobel. We didn't make these up ourselves. But Valerie, you go ahead. But we have some specific questions, and I think the point Valerie's about to make is one we should turn to in a minute. So go ahead, Valerie.
Building on that, I feel like we do need to designate that the further processed a data product is, it is a higher processing level, but there also needs to be a select all that apply sort of, subcategories within there of, is it grid, is it time series, is it emerged, is it model, select all that apply, because you can't assume anymore that higher processed data products have all of those things. And the user needs to know which ones they do have. And so that's a fundamental restructure of how we want to make that table.
Yeah, so one important question here is, are processing levels the right place for that information, or do we need additional metadata fields or something else?
Yeah, and so one question that I have about that as we try to create a taxonomy is, I think I said this before, but so to me, no metadata is better than the wrong metadata or better than misleading metadata. And so, there is the possibility that we could view processing levels as kind of a stamp, a certification, right? That we are saying, we're declaring the following things are true about this data. And if those things aren't true, we don't necessarily need a processing level on that data. Maybe it doesn't make sense for your pictures of trees or whatever on the ground. That's your ground truth data. I have no idea what processing level that should be. Users are probably not looking at processing level in order to discover that data. So who cares?
So that's, one interesting question, I think, is Valerie showed us some statistics suggesting that not that many people are using processing level to filter their data. Well, a lot of people are, but it's small in comparison to, but we don't know if that's because processing levels just aren't useful enough. If they were more useful, maybe more people would use them. It's hard to.
You didn't make the chart out of the metrics, so you
No, seriously, I need to comment on that statement.
Okay.
So I want to go back to when I was at research starting to use data, and I discovered processing level. And so first it was like, here, use this data, and I was using it, and it was like, this isn't working for me. Why not? And processing level, I learned this is the data I should use. This is the data I can't use because I don't know how to do this yet. And then this is the data that works with these tools and not these tools. And I think that's important. But we do have level 2 in the title until yesterday in the workshop. So yesterday or the other day when we had the Earth Data workshop, I never thought of looking for data by processing level. So I think that's part of it.
Yeah. I think Doug needs to say something.
So regarding that hypothesis that processing level isn't used much, I think I could bet money on the fact that if you compared any other of our search criteria compared to the total number of queries, you would see a similar thing, with the possible exception of spatial and temporal constraints.
Yeah.
So I think that's slightly misleading.
Good point. Thanks, Doug. Yeah. Okay.
It might be slightly.
So yeah, a lot of the queries are all over the place, right? You try to look at what are the top queries that you have, and the top one is other because there's all of the little tiny half percentages, right? But for instance, Aster as a facet, the Aster instrument is 15% of our daily, facet queries are filtering on that one instrument, and about 0.5% of those queries also filter on level 1 feet, right? But it's oh, okay. So I feel like processing level is used and it is useful, but it is not the first step for discovery. It's still necessary for the user to know how to use their data, but they're not necessarily using that as their first filter to find what they need.
Yeah.
I think that's what the metrics are saying.
I would categorize things like Raster
It's a different.
Yeah, it's a different.
Yeah. So anyway, I think we need to do more with
Hi, just wanted to give a perspective from new upcoming missions, and all science teams are developing new techniques, even to apply modeling at level 0 data, denoising procedures such as machine learning. How does that fit into current definitions that we have now? Because right, we're modifying the instrument data according to the level 1 definitions as unprocessed instrument data or instrument data in the processing units, but denoising doesn't actually change it to a process. It's just transformed, and so this is another element that should be considered.
I have the metric stuff once. That was a hidden slide because it didn't say much. Okay, I'll show it.
Oh, can you? Yeah. Can you just grab the,
Yeah.
do I need to stop sharing?
So I think I got it. So I think I come back to my first question. Who are we doing this for? What is it to communicate? And maybe we're thinking too linearly by just having a table of levels, right? Maybe it's not that. Maybe it's a cube of you've got a certain kind of processing age that you've got some other kind of representation that's important, 2-dimensional or 3-dimensional, where you come to a center point and you have a decision tree that helps you identify exactly the level of the designation. Let's not just call it level, the designation of what communicates. If we can figure out first, who are we communicating this for? What's the purpose of this? Exactly. And I think we can all agree in here, this isn't going to work the way it's old and it's dated and it's for satellite. Okay, so let's move on to figure out what we do need. I don't know that too much. It's on the ground. Let's get it done.
Do we all agree that they're old and need to be redone? Because I think so, but I'm not sure everybody's, so Doug's shaking his head, Patrick was shaking his head.
There's this trade-off, right?
Yeah. Well, they don't understand it.
Well,
They think they understand.
it has some, informative value to say.
Yeah.
Yeah.
And the answer is not to put the value in the file name, because you can't fit it into the metadata. That's a good start.
Valerie put up a slide. You want to?
I find this conversation fascinating, and so Deb, when you ask like who's this for, and at some point I'm like, it's for the flight project so that they can check off their requirement boxes. Because if you read the requirements for any of these missions, they are required to develop level 1 and level 2 products, and whether that means denoisifying or using AI ML, they have an idea of what. And I don't think a lot of those folks aren't in this room having this discussion. We're talking about it like after the fact, but they're designing these missions to develop like to these requirements, and they're like, oh, no level 3 or 4 data products shall be produced by this team because we can't afford to do that, or like, and so they have mappings, and they're not in this conversation. So we can have this discussion all we want for end users, but like, I just not to make it more difficult, but like to break that cycle is going to be very hard. It's my 2 rotten cents.
All right. Nobody else any burning issues? Okay, so I've got this simple one. 1, 2, 3, 4. How complicated?
I'm so sorry. I'm not always an idiot. I wanted to put, yeah, I there are some specific questions that we have been that have been given to us to consider in processing levels that, as I mentioned, came from Peter Strobel. I do think if we're going to have processing levels, right, if they're going to be something that we're requiring people to use, there are some unclear definitions involved. And I think, maybe what we need to think about is kind of not today. We don't have to solve this today, but what work do we want these to do for us? I mean, as I mentioned, they're from 1993 or possibly earlier. They haven't changed at all, but the world has. And what work should they be doing? and are they the right place for that work to get done? That's another question that I think is coming out in this discussion. Is it something, would it be better served by having, better metadata or different metadata elements that don't currently exist? Does it make sense to try to pack all of this information into a processing level? We saw Tom and his team needing to create all of these different level 2 processing level designators in order to, differentiate products. And so some questions that Peter Strobel put to us that, we don't have to answer these if they aren't interesting to us, but he finds the definitions unclear. Are georeferenced data orthorectified? That was one question. And I had to look this up. Sorry, this isn't my bailiwick. Orthorectified being kind of map projected. It's more, it's tweaked so that it fits the way it should on the given the elevations and stuff of the region, whereas georeferenced are possibly less precise. They're just, here are the coordinate points, it's here, but we haven't done any work to massage them onto different elevations and that sort of thing. The processing levels are unclear about that, he points out, so you can't tell from reading the processing level whether a data product is just georeferenced or whether it's been orthorectified. He also points out that the term geolocated appears for the first time in level 2A definition, but our previous levels, does that mean previous levels aren't geolocated? And also, can level 2A be orthorectified, right? So is that something that's actually propels it into level 3 or level 2B or something? Also, he points out that, there's the level 1B data products and level 1 are described as level 1A data products that have been processed to sensor units. And, what the heck does that mean? He's wanting to know. So we do have some, and, I had okay, great. Doug's going to tell us. He's going to say,
Not on that particular question, but the other ones, like, you can't convey everything everybody needs in 5 fixed values.
Yeah, that's the question, right? Do we need to convey it, and should we be?
One would hope that every other piece of information that he needs is described elsewhere in the metadata. That's entirely possibly not true.
Yeah,
but it should be.
Right.
You can't. I don't think you should be cramming everything into these 5 or 4. Should we talk about level 5? Not yet, right? It's these 4.
There are more than 5. I just want to keep stressing
that. About level 5, right?
Okay.
We're not talking about that.
Okay.
But yeah.
All right, then we need to stop letting people add them to GCMD keywords if
coarse-grained description of processing level to get to your first order filtering of what you probably need.
Mm-hmm.
That's basically it.
Mm-hmm.
So I'm going to jump ahead, and if Peter's online, he'll totally jump in.
I don't think he is, Patrick.
Okay. So I'll try to represent Peter as best I can, because ultimately he comes up with a recommendation here that describes processing level as a 2-axis thing. So you have probably a number and a letter, right? Like 1A, 2A, whatever. One of those axes is describing how much processing has been done on the geometry of the data, the physical location of the data. So 0 is like raw off the sensor, but then you've got terrain correction, potentially atmospheric correction, which is like a little different, and it goes up from there into gridding into a map projection. So you've done more processing on where is this point on the ground. And you may want lower because, you might be, for instance, dealing with two different instruments that their science teams chose to do atmospheric corrections in 2 different ways. So you need to go back to make it consistent. And so it might be useful to go to those lower levels, or you want it done for you because that's a lot more. The other axis is the data values themselves, how much are those processed? So 0 is like the raw radiance of the sensor, or whatever your instrument is doing. And then it goes up to geophysical variables and further on. And so he suggests that splitting those two concepts out and potentially just assigning a number in a letter or something like that conveys a lot more information and reduces a lot of ambiguity.
Do you have the matrix?
Deborah is also looking to say something.
So, but I think a lot of the legacy definitions and nomenclature that you showed, most of it is from the 1990s, the handbook, EOS handbook that Greenstone.
All of it is. It hasn't changed one little bit, not even a word.
I think it's definitely worth thinking how they should be modified. And then also, there's also a semantics issue, like orthorectification, orthocorrection. There's this geolocation, georeferencing. I mean, we need to make sure we clearly identify, sort of in unambiguous terms, what we are talking about.
Yeah, I will confess, you guys, I go level 0 data products are reconstructed, unprocessed instrument payload data. I don't know what that means. What does it mean to be reconstructed and unprocessed, right? What counts as processing? What, I don't know. Sorry. Okay. Also, Deborah wanted to say something. Sorry.
The unprocessed means the data. I think that is something very difficult.
No, I know. It doesn't help to tell me, though, but do users know? I mean,
you're really talking about electronic number. It wouldn't mean anything to anyone. The same number from the same measurement in sensor unit can vary from one sensor to another sensor. So there is not really, it wouldn't mean anything until it has been really calibrated. Right? So they have to leave it at sensor unit. It is another to digital converter. Throw some numbers, digitize it, quantify it, and give some number. That's it. So it's a sensor number. And then, depending on the sensitivity of the sensor, it gives the number. So if the level 0 is giving out the same at least numbers, so other than that, it doesn't mean anything. But remember, unless we have a process, as Katie said, the data producer is keep on making these level numbers, depending upon the request from the scientist to refine the processing levels. What correction is applied, or what additional thing they would want to do, and then this is now different than what we call currently at level 2. So I'm going to call it as level 8. So you have a new mnemonic. So that's what we have been doing. The data producer has been doing all the time. And there may be some document which say why I put this A, why I put this G, and so on. And there is no centralized process to communicate that to SDS or EFTS. So if we come up with something based on, okay, here is the one that we started with long time back. So let's go and come up with a formal process for it. So how somebody can come up with the new processing levels and how to communicate that back to SDS so they can put it in the CMR or they want to do it. So that, because at the end of it, it has to be, that knowledge has to be transferred to the user so the user knows what does that really mean so he will use it correctly. That's the whole point.
Yeah, Deborah's been waiting to say something.
I know I'm saying a lot, so pardon me, all of those who haven't spoken yet. What Patrick shared, yes, I think that it sounds like that would work well because you're separating out the factors that might be what's creating this level in distinction that makes it different. Well, Katie shared absolutely yes. You're never going to get the scientists to change that understanding. The satellite scientists.
Oh, I think we can do it. We just have to be.
Yeah.
It's not them telling us.
It's us telling them. Well, then that's good to know. That's good to know.
That's my real.
And I come back to the way we solve like the worst of the problem is that we're requiring every data set to do this, right? And that's where we're wrong because this is built for satellite. So then Rama's idea of maybe we have a different table for the other kind of data that is not the satellite that this does not apply to because we need our own perhaps level system for that. Now the radiometers on the aircraft could follow the satellite level processing because it's a lot alike, except for that it's on an aircraft. But the ground measurements, the CO2 station data, that needs a different kind of table. It doesn't work with this at all. And requiring it to give one is where the worst of the confusion's coming in this confusion. So maybe that's how we solve our problem. The different table, adjust the table we're using so we can keep kind of using something familiar and just do some adaptation here. It will work.
And I've got Benita and then Dirk and then over there.
Hi, this is Benita from Justice. I missed some of the conversations earlier, but what I'm hearing, there are two things that we're discussing, right? So first thing is whether the current definition of processing level is sufficient or not, be that for the data providers or for us as the archives. But I also hear another conversation that whether it makes sense to expose that information about processing level and use it as a selection or filtering mechanism for the user, whether we should be doing that or not. And I see only like 2% of the users are using that as a mechanism to filter the data set. And maybe they are not aware of, they don't know the definitions. It's really hard then to filter, they do not know the definitions. I was at one of the workshops and we were showing we're saying this is the level 3 data set. And the first question we get, and those were the folks from outside NASA, what is processing level? Because not everybody knows about processing level. So maybe we also, when you think about users, we need to find out a way that can relate to the users, maybe just say raw data or non-graded data or graded data for the users. But when it comes to the data providers, maybe we need to refine those categories and maybe redefine those and make it more like include the recent or the data set that does not really fit into the category.
Yeah, thanks, Benita. One thing we didn't do, and now I'm regretting it, is ask the data providers why. Why, Tom? Why are you doing all that, labeling with processing levels? And you don't have to answer right now because there's lots
Okay,
of
no,
people.
can you bring the definition?
Oh.
I think I need
Sorry.
to win some evidence back because I'm going to have a pop at airport. So my hypothesis is that these are not specific to satellites in any way, except for the examples they give. So I look at this one, it seems applicable to everybody. So does this one, but when we get to here, it starts talking satellite and all this stuff, but they're just examples of the type of data that possibly be binned in here. So, and Pepper's not back yet, so maybe I still have a long time, but I don't think these are specifically related to a subset of our platform, other than examples.
I'm Bob from NOAA NESDIS, and just to point out maybe the obvious, I think NOAA uses these in quite a different way. And Deborah's comment, because I sit in on the NOAA satellite meetings, that yeah, they're designing 2 levels and they're funded to make products at different levels. And to go back to what he just said, and Weather Service uses levels, data levels for radar data. I mean, so if you want to talk to you want to think about having a conversation about how to convey level information to users, especially. And I think NASA and NOAA seem coalescing on trying to use CMR to combine data. Your audience may be larger than you think.
Yeah, Treva did a quick review of who all uses these, and do you remember which ones you pulled, Treva? It was NASA, NOAA.
A couple of industries like Harris.
Yeah, but they were all using these processing levels, so this is, I think, pretty wide reaching.
So, going back to what Doug said, I think Doug's mostly right, but there's some ambiguity there for particularly things on the ground, like the CO2 sensor that Deb talked about. Because on the one hand, you could say that is like highly, from a user perspective, it's highly refined. We know exactly where on the ground it was, and we know the physical measurement that was being taken. It wasn't like derived or really processed in any way. So like that's why pretty like it's really good. I don't have to do much to it, I guess. But from the other perspective, if I'm worried that you might have lost some information in your processing, then to me that's like it's the unrefined data. We also could say it's like not there wasn't anything done to it. So there might be something to work out in there, but I think we could potentially apply these, or just decide that in some cases it's not useful to many people, so who cares? But I did want to go back to just because I heard Tom ask a question real quick and going to I don't know if you have Peter's table, but he had laid it out so that the number corresponded to the amount of geometric correction, and it was 1 through 4, and there was a letter that corresponded to the amount of variable correction. And it was actually pretty nice because I think the way that he had it lined up almost exactly with our current understanding of it. So there'd be a clean transition. So I don't know if there's a way to share that out, but
I don't have that that table. Because he wasn't coming, I didn't want to try to talk about it. But yes, there was. I mean, it's related to this question he asked about. There's different processing that happens to the measurement itself, right, to the observation, and then different processing that happens on the geometry side, and that those are diverging sometimes in ways that aren't captured by our current processing.
I think with permission we can share that with this group. So please remember to sign up in the attendees section on the notes list, and we can.
Yeah. Okay.
I know we all want to pretend that level 5 is coming. Community contributions level 5 is coming. And I presume the people who, we fought that last. The folks who want to use community contribution data when it shows up and it's at level 5 are going to probably want to know how processed it is too. So to enable actually useful community contributions, we're probably going to have to enable more than one processing level per data set. So it's not going to be pick the one that apply, but pick all that apply. And I don't know, maybe that actually helps remove some of our pain points in terms of these generic buckets, and we can just say, hey, well, it is graded, it is orthorectified, it is processed to this thing, and it is also community contributed. And then we have a data set that's level 1, 3, 5, and
ouch, all of them.
You do just a tag of it's a processing level. It's not a processing.
Can I jump in and ask if that is that a quality issue? Like, why do they want it? It's already a done deal?
But it's not a processing level.
It's not. How can it be a done deal if it hasn't been sent through ESCO?
Together said that this is not acceptable. I think their initial attempt. There's a lot.
Plural. There were. It's a who gathered the data. It's not a processing level.
Can I jump in too and say, you guys, we have an issue here. I'm going to back up again to this slide, but we have an issue with processing levels getting added, but they're completely unvetted. Some of them don't even have definitions. And the process, I'm sorry, I'm going to speak for ESCO here. We want these things to get vetted by the community, and the role of ESCO is to put that out there and say, is this an appropriate processing level? And so I'm curious, if that's going to happen with level 5. Did it happen? Oh, we did it? As it was an ESCO review? Oh. Oh, interesting. We're almost out of time, aren't we? We have 6 minutes. Okay. Yeah, Tom.
Just one more comment from that point of view. So for all our data products, we have algorithm description documents, and we have data format control, right? So while we generally map at the parent level to these levels, we can map ourselves to these levels, and I know there's a bit of edge, but perfectly reasonably can say we have level 1, 2, 3 type products, and when we talk amongst ourselves and people, they generally know what that means. They specifically need to know what a variant, due to the context, particular context of our processing system, what level 1 variants and level 2 variants are. They're described in our data format control books. So we have context-specific specifications that are documented.
Okay, so I think we're getting near our time. We need to start wrapping this up.
Yeah.
Thank you for the robust discussion.
Yeah.
I think we've surfaced a lot of the issues that need to be addressed. That's kind of clarified. One of the reasons we came here was find out, okay, do we have a problem? The answer is yes, we have a problem.
But we don't know what it is exactly.
We have solved it. We've surfaced many of the issues that I think need to be addressed. So one of the factors that we weren't able to bring to this, we've mentioned Stephen Strobel. He's got a proposal he's working through CEOS, which I think is useful for people here to see. So please sign up in the attendance sheet. They'll send you the link where you can take a look at that.
Yeah.
As a follow-up to this, ESCO needs to look at how we move this process forward. So we will definitely kind of involve, or at least reach out to anybody who signs up in this meeting to say, hey, do you want to participate in a future telecon or whatever we have to, as part of our next stage of looking at this.
Yeah. Yeah, I've got nothing else. Thanks very much, everyone.
All right,
This was
everyone.
really, really fun.